Hey code chasers, how are you? I hope you're fine and healthy. With that healthy vibe, we will start our video today. I am Adilakshmanatiketi. Welcome to our channel, Code Chasers. Did you know HDFS, that is Hadoop Distributed File System, follows master-slave architecture? What is master-slave architecture in detail? I have discussed in my earlier video. I'll keep the link in description. Please have a look. So now we will see in this video how master-slave architecture is implemented in HDFS, that is Hadoop Distributed File System. As we know, master-slave architecture contains master node and slave nodes, and master node manages the slave nodes. Okay, in HDFS, name node is the master node and data nodes are slave nodes. Okay, a name node can contain multiple data nodes, but at a point of time, only one name node has to be active. Name node manages the data nodes, and name node contains metadata of whole cluster. What is cluster? I have discussed in detail in my earlier videos. I'll keep the link in description. Okay. Now, I have said name node contains metadata of whole cluster. What is metadata? Metadata is the data about data. Keep it simple. Suppose if we take a person and he is residing in California. California is the address of the person. Okay. Address means it is saying something. It is saying some information about the person. I can treat address as the data about that person, right? So, now we'll replace person with data, some data. Okay, data means it will be obviously having location in memory, right? So, that particular location is information about the actual data, right? That means this address or location is the data about data. This is called metadata. That means data about data. As name node contains metadata of whole cluster, name node is very important part for us. Okay, so name node has to be enterprise hardware. What is enterprise hardware? Generally in market there are two types of hardwares, that is commodity hardware and other is enterprise hardware. If at all we take commodity hardware, the probability of failure, to keep it simple, if at all we take 10 commodity hardwares, there is a probability that one among those 10 can be a failure. Okay, but this is not the case with enterprise hardware. In enterprise hardware, the probability of failure is very minimal. So we have to use enterprise hardware for name node. If you still want to know the enterprise hardware and commodity hardware in detail, I have discussed this in my earlier sections. I'll keep the link in description. Please check it out. As I have said, the name node manages the data node. The actual data is present in the data nodes. Name node regulates the client access. That is to access the actual data which is present in data nodes. To keep it again simple, client here is we. You treat it as we are clients here, and we have to access the data which is present in data nodes. That is the actual data. Okay. Name node regulates the access. So, first of all, we have to contact name node. Name node has to give permission to us. Then only we can access the data which is present in the data nodes. Name node gives an authentication token to a client. After receiving the authentication token only, the client can access the actual data which is present in data node. That important part the name node plays here. Okay. Data node acts as a slave node. It just follows the instructions given by name node, that is master node. Data node follows the instructions of creation or deletion of blocks of data. What is here a block? For suppose if we have 500 MB of a file, okay, now Hadoop will segregate this data in the following way. It will divide it into 4 blocks. block A which is of 128 MB, block B of 128 MB, block C of 128 MB. And block D will contain the remaining data, that is 116 MB. It will segregate the large amount of data into smaller blocks and then operates on the data. Coming back to our master-slave architecture in HDFS, as I have said, the data in Hadoop will be segregated into smaller blocks. Here, the actual data is present in data node. The data node will contain those smaller blocks. Here, those blocks are B1, B2, B3, B4 in first data node. Now, if we observe in these multiple data nodes, the blocks are repeated. Why these blocks are repeated? This is for the protection of data. That is called replication. What is a replication? I'll explain detail in next video. But in a nutshell, replication means if at all we have a certain block of data, for suppose B2. If there is any damage has occurred and we lost the data in block B2, then what's the situation? There comes the replication. Replication means every block in Hadoop will have its replica. That means in case any damage of any block, the replica will comes into the action and it will allow the process to continue smoothly. Isn't that really fantastic how Hadoop was designed? What if there is a case the data node itself has damaged? Then also Hadoop has a solution. Whatever the blocks of data that were present in the damaged data node, each and every block will have replica in other data nodes which were active. This is again a beauty of Hadoop. We have to appreciate the design of Hadoop here. If we have a still large file in GBs or TBs, we can increase the block size from 128 size to our required size. There is an option in Hadoop that we will see in next section. Name node maintains metadata, right? Name node contains edit log and FS image. What edit logs do? Edit log keeps track of only recent changes that were happened in HDFS. Okay. FS image keeps track of every change that made from beginning. Till this point of our video, we came to know how important the name node is, right? What if the name node damages? Don't worry, code chasers. Hadoop has a solution for us. That is, we have a secondary name node. Secondary name node contains editlog.copy, fsimage.copy. Secondary name node acts as a name node when name node fails. It maintains copies of editlog and fsimage. Whenever a name node fails, secondary node comes into action. It will combine the earlier copy and new copy of fsimage to get the updated one. Updated fsimage contains each and every change that happened in that name node since beginning. That means since the beginning of the damaged name node. This is one of the important features of Hadoop again. In a brief about master node, we generally use this term called master daemon to address master node. Okay. Master node manages all data nodes. Master node regulates client access to files. Master node executes the read-write operations on files. Slave node, which is data node. We generally address this slave node as slave daemon in Hadoop. Okay. Slave node creates blocks as per the instructions from name node. Slave node stores actual data in blocks. Slave node performs read-write operations as per client request. One point we have to observe here, name node executes the read-write operations. Slave node, that is data node, performs the read-write operations. This is about the architecture of HDFS. Hope you found this video informative and useful. Next video will be on how the blocks are created in HDFS and how replication is being carried out in HDFS. Trust me, next video will be very much interesting. One quick information, Pyspark with Hadoop end-to-end development course is running in our channel. If you are interested, please check it out. And also, on few of our subscribers' request, I have started a Python full course in shorts playlist. If at all you want to learn Python from basics in a simple way through shorts, this is the playlist for you. Please check it out. I'll keep this playlist link also in the description. If you like my work, do support me by liking our videos and subscribing to our channel. Also, don't forget to share the videos to your friends if you feel the content is worth. Also, one thing, click on the bell icon to get notified for such useful content.